today we are going to be deriving the equation for the half-life of a radioactive substance. So let's begin. We begin by looking at the exponential decay equation for the number of particles in a radioactive substance. In this equation over here, n is the number of particles at time t, and n0 is the original number of particles. Lambda is our decay constant. What we're going to do next is just simply rearrange for the exponential. So I'm going to bring this n0 over on this side, and what I'm going to get is that n divided by n0 will be equal to e raised to the power of minus lambda t. Now, something which is very crucial to realize that when we are at the half-life, so I'm going to say when t is equal to t half-life, this subscript here just simply indicates that this is the half-life. So this is essentially the symbol for half-life. This fraction, n over n0, will be equal to a half. So if the original number of particles was 2, then at time t is equal to the half-life, the number of particles will be half of that, which is 1. So n over n0 will be equal to a half. So a half will be equal to e to the power of minus lambda t, and I'm going to indicate that this over here is the half-life. Because we want to rearrange for whatever is in the exponent, I'm going to need to take the natural log of both sides. So I'm going to say that ln of a half will be equal to ln of e to the minus lambda t halves. Now the natural log and e are two inverse functions, so what we're going to get on the right hand side is just what's in the exponential. So we're going to get that the ln of a half is equal to minus lambda times the half-life, like so. Perfect. Now let's rearrange for the half-life, and what we're going to get is that the half-life t halves is going to equal to ln of a half divided by, or minus ln of a half divided by lambda. Now remember, due to the properties of logarithms, feel free to brush up on those if you're not quite certain, but every time we get a negative sign, this will actually flip the fraction inside of the logarithm. So what we're left with is that the half-life of a substance is equal to the natural log of 2 divided by a lambda. In fact, in your formula booklets, this equation is given as the natural log of 2 is equal to the half-life times the decay constant lambda. Okay guys, well, we have derived this very important equation for the half-life of a radioactive element. Thank you very much for watching, and I'll see you in the next video.